Linda used to be my boss, and I think it was like 10 years ago where she called me into her office and said, "What's our analytics strategy?" And I said, "What?" And she has been a mentor and inspired me to get into this field. So my remarks are going to be about, I head up the research division of McGraw-Hill Education. I'm going to talk just a little bit about open science, and nothing that I'm going to say is any different from what Ken mentioned this morning, but I want to highlight sort of three themes that were implicit in Ken's remarks. So I think theme number one is when we consider open science, learning analytics as a discipline, we don't really have clarity in what are the known knowns. So we think of mature sciences like physics. If you go to a physicist and say, okay, what are the known knowns? What are the big results? That's not the case. We don't have agreement or understanding in the research community of what are the results that improve learning outcomes. Okay, so one thing that I want to highlight is as a research community, and if we're really going to do open science, then we need to start to march towards clarity and understanding, a common understanding of what are the known knowns, and then begin to apply that. So an example of that is this really a known known? And Ken started with that, of is the teaching mode of instruction effective in STEM? If it's not, where's the Martin Luther or the Martin Luthers, nailing on the walls of every university to say, well, let's get rid of this stuff, right? So is it a known known or not? Second point, and this is tied to the known knowns, you don't really have a science until you have reproducible results, right? Now, for that, it's not just replicating the results and having peer-reviewed journals, because learning analytics, and this is across the board now in most of the major sciences, it's data-driven discovery. And so for replicating results, other researchers need to have access to the data and also the computation. So Ken's research paper that he published recently, he talked about, one of our researchers, data scientists on my team said, hey, this looks really interesting. Ken, can we have the data? And he said, yeah. And we started to look at it, and it wasn't that we thought Ken's results were off, but it was very interesting. And can we build on that result, right? Now that doesn't happen. That's not very common. It's very, very difficult for researchers to get access to the data, to replicate the results, and then to build on that. Third point, I'll finish with that, is I call this the scourge of p-values. Most of the results that we see say, oh, we found this thing which is statistically significant, this improves learning outcomes. P-values don't tell us very much. It's really effect size. So what we want to understand and what we want to know is what's the effect size of a particular intervention. So when we talk about improving learning outcomes, effect size, not p-values.